Hello guys, so we are going to continue the discussion with respect to chain rule of derivatives. In this video, we are going to see the composition of three functions, okay? And when we discussed about composite function, some of the examples that we have already taken in our previous video was with respect to two functions. One was outer function and one was inner function. Now similarly, there may be n number of composite functions. That basically means there will be different functions inside another functions. Just by showing you this example that if we have a composition of three functions, how you can go ahead and do the derivative. Similarly, you can go ahead and understand with respect to n different functions whenever there is a composition of them, right? So let's take an example. Let's say that here the y function that I'm actually going to do, I'm going to initialize this sine 3x. Okay, so we are just going to consider this function. Okay. Now let's focus over here and let's see that what all information you have in this particular function, right? So first one is your step one, right? Now in step one, we basically identify the functions itself, right? Now in this case, just pause the video and just try to understand like how many functions are specifically there, okay? Just think over it. So I can probably go ahead and think in this way. Let's say that this is my one function, this is my another function, and with the root I have my another function. So in this scenario I have three composite functions, right? Three composite functions. So first of all, let's go ahead and identify the outer function. So the outer function I will go ahead and specify by f of u. Let's say f of u is nothing but I will consider this entire function with the root, and let me just go ahead and replace with u, right? And that is the reason I'm writing f of u. So this is nothing but this is root of u. Okay, so I'm considering this entire thing. Here u is nothing but it is sine 3x. Okay, so this basically becomes my one function, right? And I can also go ahead and write this as u to the power of 1 by 2, right? Then we go ahead and talk about the middle function, right? Middle function. So in middle function, let me just go ahead and provide a notation with g of v, right? Now in this scenario, there I have something called as sine 3x. Okay. Now g of v will nothing be but it will be sine v, right? And here your v will be specifically equal to, what will v be equal to? It will be equal to if I probably consider this, it will be equal to 3x. Okay. Then your inner function obviously you know, because we can also specify this v is equal to, here I will specify with this function which is nothing but h of x, which is equal to 3 of x. Now this is what I have identified, right? Just by seeing this particular equation. This was my most inner function, this is my middle function, and this is my outer function. The outer function I have used as square root of u. That is what I have done. U is basically nothing but sine 3x. So when I write g of v, this 3x will now get replaced by v. And then you have this v which is represented by 3 of x, right? Now let's go to the next step with respect to differentiating, right? So let's first of all talk about the outer function. If I go ahead and write f dash of u is nothing but it will be equal to 1 by 2 u to the power of 1 by 2, which is nothing but 1 by root 1 by 2 root of u, right? That is how you can specify this. Okay. Now let's go ahead and talk about the middle function, g dash of v. You know that g dash of v is what? What is the derivative of sine v? It is nothing but cos v. And then finally you have this h dash of x, which is nothing but derivative of h of x with x, which is nothing but 3. Okay. Here we have done the derivative with respect to v. Here we have done the derivative with respect to u, right? So if you really want to specify this in the form of, let's go ahead and specify this in the form of chain rule. Okay. Now I will go and show you this in the form of chain rule. So apply the chain rule. And now let's go ahead and write this. So y is my function. So I'm just trying to find out derivative with y with respect to x. So first of all, I will go ahead and write derivative of f with respect to derivative of u, then derivative of u with respect to derivative of v, Okay. And finally, I can go ahead and write derivative of v with respect to derivative of x, right? This is what we have actually done. See, f dash of u, we have calculated g dash of v, we have calculated h dash of x, we have actually calculated. Right, now let's go ahead and replace this. What is derivative of f with respect to u? It is nothing but f dash of g of h of x, right? This is what my entire composite function is. Then what is derivative of u with respect to v? You know what u is? U is nothing but sine 3x, right? So I can go ahead and write this as derivative of u is nothing but g dash of h of x, right? Then finally, derivative of v with respect to x, v is nothing but it is 3x, right? 3x. So for this, I can go ahead and basically write h dash of x, right? This is what it specifies, each and every notation. This is this notation, this is this notation, and this is this notation, right? And more, if you want to probably go ahead and simplify it, you can go ahead and write. So what exactly this is, we have already calculated this, So let's go ahead and see the derivative over here. So with respect to this particular derivative, you can go ahead and replace it, right? So I know, first of all, what is f dash of u? F dash of u is nothing but 1 divided by 2 root u, right? So here I will just go ahead and write 1 divided by 2 root u. What is u? U is nothing but, let's go ahead and see what is u, sine 3x, right? So here u is nothing but, I will go ahead and write it as sine 3x. So this will be nothing but 1 divided by 2 root sine 3x, okay? Dot, okay? Then what is g dash of h of x? G dash of h of x is nothing but sine v, right? And v is nothing but 3 of x, right? So here, when we found out the derivative, it is nothing but cos v. So cos v, here instead of writing v, I will write cos 3x dot. When we do the final operation with respect to h dash of x, it is nothing but 3. So here is my total output, derivative of y with respect to derivative of x, 3 cos 3x divided by 2 root sine 3x. So this is the overall derivative, and this derivative you can actually find out for composite functions, like for n composite functions. That basically means you can have multiple functions in the form of composition, right? One after the other, one after the other, one after the other, right? So this in short was about chain rule, but with respect to anything that you have, right, you will be able to see that when we try to find out the derivative, we are just trying to find out the dependencies one after the other, right? X was probably dependent on v, v was dependent on u, u was dependent on f, like this, right? And we are able to combine this in the form of chain rule, right? Now quickly, I will just go ahead and probably provide this conclusion about chain rule, and this will be important because once you start your deep learning, I have also made sure that one algorithm of ANN in deep learning I have uploaded in this course itself so that you get an idea. The chain rule is a powerful tool in calculus for differentiating composite functions. By breaking down the differentiation process into manageable steps, it allows us to compute derivatives of complex expression efficiently. Understanding and applying the chain rule is essential for solving a wide range of problems in all this. What kind of problems and all? Because as we go ahead, we will be seeing multiple algorithms. I'll be putting 3 to 4 algorithms from machine learning, deep learning, and like that, right? So that you get an idea like how this entire linear algebra, stats, or differential calculus is specifically used. And this chain rule has really an extensive applications whenever you want to really apply in neural network, right? So that is what I'm also going to cover as we go ahead. So yes, this was it from my side. I will see you all in the next video. Thank you.